All right. Okay. All right. So morning again, students. So today we're doing a new topic, which is coordinate geometry. We're gonna do it in 2 classes. In the old system, I would basically do it in 1 class in the classroom. Right? Do the topic in 1 class. Because we're now doing 3 classes per week, I can do part of the topic today and do the second part of the topic tomorrow. All right. So this class has the functions class. It has several mini sections, comprising of about 23 slides or 22 slides. What I'll do, maybe do about 12 or 13 of them today. Take us up to a point. And we'll break, give you a chance to revise those. We did, watch over the video later, stuff like that. And then we'll pick it up back tomorrow. And then we'll pick it up back tomorrow. Now we'll finish the last set of sections, the last few sections. And after we finish the last few sections, then we'll do a couple questions. That is tomorrow. And then Wednesday now is the normal class. We'll practice some more questions, and then I'll give you some work to do. All right. All right. And then as usual, I'm begging you to do the questions and send your solutions. That way you can learn from your mistakes. Persons will tell you that when they send me their solutions, I might not respond same time, same day, but eventually I respond, right, to each person. Some persons are sending notes and say, I can correct this, I can correct that. Some persons are called because I feel like it's easier for me to just call them and we discuss it. And sometimes I set up a Zoom session with those persons and we just go through their work individually. So persons who are not doing their work and sending it to me, you're basically missing out on these things. And each person I do that with are better for it. They are better. Right? They improve, they learn from the mistakes and so forth. So each person need to use that facility that I'm offering. Do the question, send your solutions to me on WhatsApp. I look at it and I give you a response and I say good, or maybe made some mistakes here. I'll point out the mistakes to you. All right. So yeah. All right. So this question over here was a classwork that we did in the last class. Yeah, let me get this going. All right. Hold on. Just give me a second. All right. Okay, so this is a question that we did over here in the last class, right? It's basically a past paper question, comprised of past paper questions. And it's actually like 3 different past paper questions. All right, so this is 4. This is 1 question. That's another question. Oh Lord. All right, so this is 1 question. Bear with me with this thing. Technology kind of messing up sometimes. 1 question, that's another question. This is yet a 3rd question. And then this question really is a variations question, question 4. So it comes in like a different topic. But just that variations as a topic comes under the functions section of the syllabus. All right. So one sec, guys. And I'm getting some solutions now. People sending me solutions now. Can you help me? Can you help me now? It's too late. All right. And some person send me solutions just before the start of the class. I can't help now. I've gone past that. All right. So this question says, given that f of x is equal to 3x minus 4. So this is what we're given. Let me get the pen. All right. F of x equals 3x minus 4. First part wants us to find f to the minus 1. That's the inverse function I want. So we can just inverse this right away. All right? Inverse it. F of x becomes x equals 3. X becomes f to the minus 1 minus 4. All right? And then we're trying to make this the subject. Trying to make that the subject. All right? Oh, Lord. All right, just bear with me with this thing. It's first time I'm using it. Right, we're trying to make that the subject. So to make that the subject, we need to get this 4 over here and add it and then divide under the 3. That is a procedure. All right, so when we do that, what is going to happen is that the f to the minus 1 is going to be equal to x plus 4 after we carry over the 4 and then we're dividing that by the 3. That is the f to the minus 1. Okay, and put it as f to the minus 1 of x. F to the minus 1 of x is that. All right. And then the question says, hence. So over here, the keyword is hence. Hence. Hence means you have to use this result to solve this. That's what hence means. You know, use what I just asked for to solve that equation. Now, what some persons did was to go ahead and do 3x minus 4 equals 5. And they just solve it normally. They care about the 4 and they say 3x equals 9 when they care about the 4. And they divide by 3 and they say x equals 3. But this is not what they want. But the question said hence. The question wants us to use this thing up here that they just asked us to find. All right. So if you don't use that, you're basically not answering the question. All right. And you have to answer the question. All right. So let's do the hence method over here. So now it is hence. We are solving f of x equals, not f of x yet, not f of x, my bad, not f of x yet. We're solving the whole thing first. Let's show the whole thing first. So we're solving 3x minus 4 equals 5. That's what we're solving. But we have to realize that this side really is f of x. So it's really f of x equals 5. This thing is f of x. You can see it on the side over here. That is f of x. So we're really solving f of x equals 5. So this right here is really f of x. F of x. Let's get that. I'm thinking it a smaller ink, a smaller pen. Not the smallest. All right, no problem. So this really is f of x equals 5. This thing. So that's what we're solving. F of x equals 5. Now remember the rule. This is the rule that we're using over here. This is the rule that we're using. The rule that we're using that we did in class is this. If f of x equals some number, then, and that's an equation, you know, f of x equals some number is an equation that they're trying to solve, then x is f to the minus 1 of that number. Because that is when the function is a one-to-one function, in which this is a one-to-one function. That's the rule that we're using. So if we come back here, we can say this implies that x is f to the minus 1 of the 5. And so we're using this f to the minus 1 of x up here that we have. All right? So we're going to put the 5 in that. So if we move this up, we're going to say, therefore, the x that we want is 5 plus 4 over 3, because we're using this thing up here that we have, using it down here. Because that is f to the minus 1. All right, this is over 3, not that, over 3. All right, and so that becomes 3. As that's 9 over 3 is 3. So you get the same 3 over here now. Same 3 we get right there. But that's not how they want it. They want it done this way. But understand that? But good so far?
Yes, sir.
All right, nice. All right, so let's move up to the next one. All right, let's go to another page. All right. All right, so question 2 now. Question 2 says, find the value of x, all right, and that's over here now. Find the value of x for which h of x equals 4x plus 5 divided by 2x minus 3 is undefined. That's a fraction. A fraction is undefined when the denominator is 0 because you cannot divide by 0. So we're looking at question 2 now. All right, looking at question 2. So we can say h of x, which is equal to 4x plus 5 divided by 2x minus 3 is, let's try that better, is undefined when you have to divide it by 0, or when the denominator is 0. When the denominator is equal to 0. Because when the denominator is 0, that calculation will be error. The error calculation or syntax error calculation on the calculator. And so you're trying to find x. So the question is saying, find the value of x here. Find the value of x. That's what they want. The value of x. All right. So if we come back over here, to make x a subject, you care about the 3 and divide by the 2. And so the x equals positive 3 divided by 2. Any questions there? But good?
Yes, sir. Yes, sir.
Over it is very easy. When you have a fraction, if you ever have a fraction, A over B, any fraction, right? This fraction cannot have any result. No result. It has no result if the B is equal to 0. And you can try it with a calculator. Try any value. Try 10 over 0. The calculator is going to say error. Cannot work. Because remember, to divide by 0, you're basically counting how many times you can remove 0 from 10. And no matter how many times you remove 0 from 10, you're still going to have the 10 left. When I'm doing 6 divided by 2, the answer is 3. Why is that? Because I can remove 2 from 6 3 times. There are 3 2s that exist in 6. But how many zeros are there in 10? An infinite number of zeros are there in 10. Because no matter how many times you try to group zeros out of 10, you're gonna still have your 10 left. No matter how many times you try to take 0 out of 10, you're still gonna have your 10. So this is an undefined quantity. So this is equal to a symbol that's written like this. That is a symbol for undefined. This means undefined. I want to see it other places in maths. In fact, you're gonna see it again today. And you're gonna see it when we do matrices. This means this is a symbol for undefined. Undefined quantity is a quantity, as it says, not defined. You don't know what it means. It's undefined. It's an undefined quantity. It's a value that is so large you cannot quantify it. You don't know what it means. All right? That's what it is. That is undefined. It's not allowing me to write anything more until the right here. All right, that is it. But that's what it means. Undefined, not defined. Because you cannot quantify what the result of that calculation is. And 0, the value 0. But you know what 0 means? 0 means nothing. 0 means nothing. This means none or nothing. It means none. None or it means nothing. So if you have 0 apples, everybody know that 0 apples means say you don't have any. We know what 0 means. We know what 0 means, right? So 0 is a defined quantity, right? So So that's all that means in this question. We have this fraction right here, and I want to know what value of x. Remember, you can give the x any value, basically, you can give x any value. You can give x a value of 1, you can give it negative 1, you can give 3, you can give 15, you can give a half, quarter. You can give this value, this x there, any value you want. And every time you give x a value, the whole thing will work out to something different. For each value of x that you give it, you're going to get a different result. But what happens is that there's a point, or there's a value of x, that when you give x that value, the fraction cannot work out. It is not defined. Fraction is not defined for that value. And all I want you to do is tell them what the value that is. It's not allowing me to write past here. Right? It's just asking you, what is that value? Not defined. Let me just write DEF. Not defined. There's a value which is not defined. And that value is the value that will make the denominator. That value is the value that will make the denominator 0. So whatever x value will make the denominator equal to 0 is the x value that will make the fraction there, the h of x, which is a fraction, undefined. And that's all we have to do to find the value therefore. Put the denominator equal 0. Right? Because that is when it is undefined, when the denominator is equal to 0. So that's what we do here. Right there, put the denominator equal 0. And the calculation tells us that that value of x is that. That is the value of x. And if you want, you can try it, because if you put the value of x right here, the 3/2 right there, then this denominator is going to become 3 minus 3, which is then 0. 0. All right? And that is when it is undefined. All right? So it's basically that. All right? So understand it better?
Yes, sir.
Even though I didn't have to do it, but let's explain it a little bit more. So that is what is happening there. All right? So we basically finish with question 2. All right? So I'm going to go on the next page for question 3. All right. So question 3 now. Question 3, it gives us a composite function. See, this is a composite function they give. And they tell us on the question that is a composite function. That's a composite function. And this is our composite function right here. All right. So that's our composite function. So let's rewrite it. So question 3. So it gives us this composite function, and it is f of g of x equals 3 into 2x minus 1 plus 2. That's the composite function that they gave us. All right? That's the composite function that we're given. And after they give us that composite function, they want us to find the g of x and the f of x. That's what it says in question 3 right here. Right there. Find the g of x and the f of x. All right? That's what it wants us to do. So it's basically breaking the composite function into 2 simple functions. So what is the procedure that we discuss? We say let the inner function, which is this one, let the inner function, which is this one, let it be equal to the expression that is within. That's our expression within. Put that as your inner function. That's the procedure. Right? Find the inner function first. When you have f and g, f of g, g is called the inner function or the first function. All right? And what you do, you let it equal to the expression within. But remember, we are reversing the process of how we find the composite function. To find a composite function, we'll put one function into another. So to break a composite function, you take one function out of the composite function. That's what you do. So after we do that, then let's use a different color to show this now. Then after we do that, we put back x in the place right here. Put x in there. Replace that with x and also replace this with x. Because remember, when you're forming a composite, basically replace x values. We substitute for x values. So putting back x in there and x in there. Right? And that basically, oh Lord, this thing advertising all kind of thing. Let's see if I can take it off, right? And then what happens now, I'll go back for the black. What happens now is that I can say, therefore, the g of x is equal to the 2x minus 1 that is there. Right? 2x minus 1. Right? And when I take out the g of x and take out the 2x minus 1, I'm left with the f of x. So I can say, therefore, my f of x then becomes 3, if I put by the bracket, 3x plus 2. But I don't need to show those brackets. All right, let me see maybe I erased thing here. So, what is the erase again? First time I'm using that. This is the erase. I can erase that. No, it's not erase. Yeah. All right. So I get 3x, and then I have the plus 2 up there. So that's my f of x. Let me bring this closer. 3x plus 2. 3x plus 2. So that's my g of x and that's my f of x. That's the answer for the first part. That is A. That is part A. All right. Now we'll come to part B now. Part B says find g to the minus 1 and find f to the minus 1 and hence, see the keyword again, hence. Hence means you have to use these two things. They don't want you to find it the normal way or straight. Right? They don't want that. They want to use a hence method to find it. Right? So that's what that means. Right? So let's go. So that's part B now we're doing part B. So we're gonna start with the g of x, which we're gonna call g, and put it back as 2x minus 1. And we're gonna inverse it. When we inverse it, the g becomes x, and the x becomes g to the minus 1. So this then is 2g to the minus 1 minus 1. And then we're trying to make the g to the minus 1 a subject. So we're going to carry over the minus 1 and add it and then divide under the 2. That's our procedure. All right? So then we're going to get g to the minus 1 equals x plus 1. Okay, about the 1, we get x plus 1 divided by the 2. That's our g to the minus 1. Let's move this up. I'm going to do f to the minus 1 right beside it. So let's do f to the minus 1 beside it over here. So I want to start by saying f equals 3x plus 2. And we're going to inverse that. When we inverse that, the f becomes x. And the x becomes f to the minus 1. And they're adding back here 2. And I'm trying to make f to the minus 1 a subject again. So I'm going to carry over the 2 and subtract it and then divide under the 3. All right? That's all we have to do. So my f to the minus 1 that I'm going to have left on the right side is going to be equal to the x minus the 2 when I carry it over divided by the 3. And those are my f to the minus 1 of x and g to the minus 1 of x. I can put in back of x behind it, yes or no. So I can write of x and of x. And those are what they wanted over here. See? G to the minus 1. I wanted G to the minus 1. Oh, the wrong thing up. Da, 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 da. Right, I wanted this and that. So we found it. So we're going to do the hence part now. The hence. All right, so let's go back for the block. So we can do the hence part. All right, so we're here. It's almost finished. So the hence part now. So we're going to say hence. They want us to find f to the minus 1. No, not f to the minus 1. You have to write it the correct way, you know. It's like one of the mistakes some persons made. You have to write it exactly as it is there. So it's fg bracket to the minus 1. You have to write it like that. You can't write it any other way, guys. It has to be right properly. Has to be written properly. That's f to the fgr to the minus 1. That's the inverse of a composite function. And somebody worked out straight, so they're not getting the marks because they didn't use the hence method. You have to know now that this thing, let me go for the blue and show you. You have to know that this thing is equal to the g to the minus 1. If the g is first in here, if the g is second in here, sorry, it comes first out here. All right, we know that. All right, of f to the minus 1. So we're compositing the f to the minus 1 and the g to the minus 1. And what does g to the minus 1 of f to the minus 1 mean again? Let's look at it. Let's use the red. All right, remember, it means this one into this one. That's what it means, you know. The f to the minus 1 into the g to the minus 1. So it means that we're taking this one right here. Use the blue to show the one that we're taking. It means that we are taking, all right, let's use the blue. All right, let's try the point. It means that we're taking this whole f to the minus 1 right here. I'm gonna bring it and put it here in the g to the minus 1. That's what we're doing. That's what we're doing. All right. So to show that calculation right here quickly, it becomes, put it beside it. It becomes equal to. Becomes where the x is, I'm putting all of the where the x is, I'm putting all of the f there. So I'm gonna put x minus 2 over 3. That's where the x was. Plus 1 beside it. Don't look so good. Plus the 1 beside it, and then you're dividing all of that by 2. If you leave that as your answer, I'll give you your marks in there. That's fine. But generally speaking in maths, you must always try to simplify. And to simplify this, what I can do is try to get rid of the fraction up here. So I'll simplify that fraction, right? So I can do that simply by multiplying, oh Lord, delete the thing. By multiplying the numerator by 3 and multiply the denominator by 3. Right? Multiply the numerator by 3 and the denominator by 3, and then this is gonna give us x minus 2 plus 3 over 6. Understand that? Because the 3 cancels this 3 first. And then the 3 times 1 is this 3 down here. All right, and then this 3 times 2 is a 6 under here. All right. So this can work, this now work out to final thing. See if it can write it, can't write it anyways. Final thing is X, not allowing me to write it. I'm just write it on the right side. It's not allowing me to write it over there, guys. So let me put it over here. So we can write IE, that is X plus 1 over 6. Now somebody got this answer doing it the other way now. We're still not gonna get the marks because I did not use the hence method. Hence means that you must use this right here. You must use that. That's what hence means. They don't want you to work this out straight. They don't want you to work out this straight as you did it. Right? The one person who did it that way. Right? Once it says hence, the good thing doing now is that in the exam they always say hence or otherwise. Alright, so you're kind of lucky that they always say hence. But if they ever say hence alone, you have to do it this method. Alright, so that is that. Alright, everybody good so far?
Yes, sir.
Yes, sir.
Yes, sir.
Alright, moving right along. So,
Sir,
yeah,
kind of understand number 1 though.
you can understand number 1.
Yeah.
I know yourself. You know, get everything fully today. So, you know, know yourself. We can always link up and we'll go through them. Alright, if you need to. I'll send you the video after when we taught it and you watch the video and you'll understand it better. Guaranteed. Because when we're doing the class up front, we explain everything from scratch, from the very basics. But there's not the time to do that now. I would have gone through the basics so persons would understand what we're doing now, persons who are in those original classes. So I'm going to send you those videos and get a chance to watch them. All right? And bring yourself up to speed. You're not going to understand you're not going to understand everything fully right now. But don't worry about it. We'll catch up. All right? All right. Number 4 now. So number 4 is a variations question. I think this question was well done. Most persons did it right, and you know, persons who sent me solutions, most persons who sent me their solutions. It was a good attempt, good work. All right, so we'll do number 4 now. Over here, continue working with the blue. So it gave us that here. Let me leave it here. I can always mark on this side if I need to write anything. All right. So the question said, given that y varies directly, so when you see the key word you're looking for is either directly or inversely. So it says directly. So this is a key word, directly. And it is a square of x. So you know it is a square of x. Now the square of x, remember, is x squared. So what they're saying is y is directly proportional to x squared. That's what that statement means. Y varies directly as a square of x, or y is directly proportional to x squared. It says use the values of x and y from the following table to calculate the value of p and of q. All right, so this is a variations question. And if y varies directly as x, then we know, let's do it on the right now. Based on what they have said, what they have said, the y is going to be equal to a constant times x squared. That is what the statement means. Right? When we say y is proportional to x squared, this therefore means that, but we don't have to write this one. We don't need to write that. Right? That is just a statement in symbolic form. Y is proportional. This thing right here is a symbol for proportional. Right? When it's directly, is k times. If it was inversely, instead of directly right here, if the question had said inversely instead, right? If the question had said inversely, let me not erase anything yet. Would have written y equals k divided by x squared instead. If the question was inversely, it's an inverse variation. But it said directly, so we're working with the first one. All right. So working with the first one because it said directly. Now, your first aim, as always, is to find that k. Some questions, k is a constant of variation, or a variation constant. Some questions will ask you for the k. Some questions won't even mention anything about a k. But you have to know the k is a constant of variation. So I always say find K first. Always find K first. What do you use to find K first? They will always give you a pair of values, whether in a table, see them here? A pair of known values, either in the table or they give it to you in words that you're going to use to find a key. So this pair of values is what you use to find your key. You put those values in that formula, y equals kx squared. So let's look at it. So the table is saying x equals 2 when x equals 2, y equals 8. That's what the table is saying. Put those values in this formula. Put them in the formula, and it will work out the k value for you. So the y value is 8 equals k times the x value is 2. So it becomes k times 2 squared. 2 squared is 4, and so the 8 is equal to k times 4. And if you just divide under the 4 there, you'll see that the k equals 2. All right? I can look at it from right here. I know so 2 times 4 is 8. So anyway you want to look at it, the k equals 2. So we can say therefore k equals 2. Now that we know that the k equals 2, it means now that we can write this now. So I'm going to go for a different color now, just to emphasize the point. Let me go for a different color. Let's go for purple now. All right? So because the k is 2, the k is 2, I do that. I'm not. Instead of back, right? Because I know that the k is 2 now, I can now write this formula fully. This formula, therefore, based on the fact that the k is 2, this formula really now is y equals 2x squared. Because while the x values and the y values are changing, constant will not change. The k is a constant, it's not going to change. So therefore, this now will determine everything for us going forward. All right? That's the formula we're using to answer for the P and to answer for the Q. All right. So it means that we're going to use the value. So we have found the table, the equation fully now. So that equation governs everything else, everything that we need now. So if we look at the table over here now, we're going to work with this one first. That column first. We're going to do that. Let's do that part over here. All right, let's do it here. And that is saying an x equals what is it? -1, y equals p. So you put those values in that table. You can say therefore the p, which is the y value, is equal to the p, which is the y value, is 2 times the x value of -1 squared. Sorry, 2 times -1 squared. The -1 squared is +1. So this is really p equals 2 times 1. Because the -1 squared is 1 and 2 times 1 is 2. So the p equals 2. All right. And then we use the same values, the same formula for the second pair right here. This one. Right here. All right. And that pair is saying that the x is q. When x is q, the y value is 18. Put them in the formula again. So we can say therefore, the y value is 18 is equal to 2 times the x value is q. So you get q squared. And we're trying to find the q. So what do we do now? So I divide by the 2. Divide by the 2 first. Divide by the 2 here first. And I get 9. All right, I get 9 because 18 divided by 2 is 9 equals q squared. And then to get the Q, I square root both sides. So I get the square root of 9 equals Q. But it can be plus or minus, you know, because when you calculate square root, it can be plus or minus. But look why it's not, why the minus not valid now. Why is the minus not valid? Because if you look at the table over here, why is the minus not valid? If you look at the table, remember it's a direct variation, you know. So as the x values increase this way, right? As the x values increase, let me erase that. As the x values increase this way, the y values must increase as well this way. Because the question says a direct variation. So there's no way this value can go back down to -3 because it already reached 2, right? And this increasing as well. So since the y value is increasing, the x value must also increase. So it cannot be -3. Everybody understands that. Understand that? So that's the reason why we don't choose a negative in this case. Another question, if it was a case where the value is supposed to decrease, then you'll have to know that you have to use the negative. All right? So in this case, the Q not allow me to write under there. So I'm just write it over this side. So this means from there now means that my Q equals +3. That's my answer. Q is not equal to -3. -3 not valid, so we have to just use a +3. All right, so this right here is my answer. That's that. So far, so good? So far, so good? All right, nice. So that was the classwork. All right, that was. All right, so what we're going to do now, we're going to jump now into the coordinate geometry, which is the new topic that we're doing. All right. All right. Yeah. All right. So coordinate geometry, guys. Let's go straight into it, right? Coordinate geometry is the XY business with graphs and all these things. Simply put, right? Cartesian coordinate geometry. All right. So coordinate geometry is concerned with the study of the properties and the properties of and the relationship between geometric objects. Geometric object we're talking about are points, lines, and curves. And we're talking about coordinate geometry is when we are using Cartesian coordinates in the XY plane. XY plane is this thing right here that we're looking at. Right? That is what the XY plane is. Right? This thing right here is the XY plane. All right. What are the things that we're supposed to know? We're supposed to know how to locate a point in the XY plane. We're supposed to know how to calculate the length of a line in coordinate geometry. We're supposed to know how to find the midpoint of a line and use the midpoint of a line in coordinate geometry. We have to know how to calculate the gradient of a line, of lines and curves. We're not going to do the curves today. We'll do the curves later down. Today we're focusing on lines. All right. So we're going to have a class later down, much closer to the exam. We're focusing on how we get the gradient of a curve. That's what we're doing a topic called rate of change. And so we're focusing on lines today. We have to know how we get the equation of a line and curve, but as I said, today's a lines day. So equations of lines and understand equations of lines and read equations of lines. All right, in coordinate geometry form. You have to know about parallel and perpendicular lines and the relationship between them. All right? How to identify when lines are parallel, when they are perpendicular. How you can calculate the gradient of a parallel line if you know one, or well, actually no calculation, perpendicular line if you know one already. The relationship between parallel and perpendicular lines. All right, we have to know how to find the point of intersection of lines and curves. Now, we actually do this already when we did quadratics, because we did simultaneous equation of a line and a curve when we did quadratics. All right, for the intersection of two lines, then is again simultaneous equation of two lines. So this one we're not going to do this one right now. Intersection of lines and curves, and intersection of lines and intersection of curves. Because we do it already in quadratics. All right. Angle between two lines. We're also not going to do this until we do trigonometry. So the last two we're not going to do. So we're doing the first 1, 2, 3, 4, 5, 6, and some other little nice things we're going to do as well along the way. All right. So these are the things that you have to know how to do for your exam. All right. And then area of shapes. We're also not going to do area of shapes until we do polygon. That topic, polygon and some mensuration and stuff. So the focus, as I said, is the first 1, 2, 3, 4, 5, 6, right? All right. All right. So let's go straight into it. Locating a point, and everybody's supposed to know this. So sliding through the easy parts. How do we locate a point on our graph? All right. The points are located using the origin, which is 0, 0 as a reference. So think of a graph. Right, there's a point where the y-axis and the x-axis, the y-axis and the x-axis intersect. That is your 0, 0 point. 0 is the x value there, and 0 is the y value there. And all other points are then located in reference to that point. That is like a starting point. All right, so that is your xy plane we're looking at. All right, that's the xy plane we're looking at. Okay, and see the scale there for the x-axis. Every line is 1, because you skip the line and jump to 2, then skip another line and jump to 4, skip another line and jump to 6. So every line is 1. Similarly, on the y-axis, you're skipping a line to go to 2, so it means that the line between the 0 and the 2 is 1. The line between the 2 and the 4 is 3, and so on, right? And let's say we want to locate the point A64. The point A64 will be 6 units to the right of the origin O, because it's positive, it's a positive value. So when the x value is positive, you go to the right. And the 4 is going to be 4 units upwards after that. So it's 6 units to the right, 4 units upward to locate that point A. I'm going to put it on the graph right here. What can you see that point A on the graph?
Yes, sir.
If you understand,
Yes,
but I
sir.
understand that. If you don't
Yes,
understand,
sir.
let me know. I'm going to go through this part, assuming that you know most of this already. All right. So if I'm locating another point B, where the coordinates are -4, -3, the -4 means that you go 4 units to the left from the origin, and the -3 means that you go 3 units downwards. All right, and you start at the origin. All right, so that point is right there on the graph, that point B. But I understand that point. That will be the point, -4,
Yes, sir.
-3.
Yes,
All right,
sir.
good. Can fly past this thing. Nice. All right, so for any point PAB, A is the x coordinate and B is the y coordinate. All right, A is the x coordinate and B is the y coordinate for any point. All right, bam, length of a line. So length of a line, midpoint of a line, gradient of a line, them come down to some simple formula or formulae. So there's a length of line formula that you need to know. Because I won't ask you to prove it in CXC, you know, but it's good if you can understand how that line, how that equation came about. All right, so let's look at this. All right, so if there are 2 points, A, which I'm calling coordinates XA, YA, and B, which I'm calling coordinates XB, YB, and you can see those 2 points on that little graph there. All right, and let's say that there's a line segment between them, and I want to find the length of that line segment. All right, so you see the dimension that I'm putting in the diagram. So You can see this dimension from here to here. And that length is xb minus xa, because all of this will be xb now. All of that. And all of this is xa. So if you want the piece between it, between here and here, you have to subtract xb minus xa. All right. Similarly, that's how we get the yb minus ya to be that height. So that length is yb minus ya, and this length is xb minus xa. And what we have really is a right angle triangle. This is the right angle triangle right here. And over here is the hypotenuse. Now I know we don't do this topic yet, because we're gonna learn this in trigonometry. Pythagoras' theorem. And that's one of the things about math sometimes. Sometimes you have to learn something before you learn something else. And you know, is that what comes first, is chicken or the egg scenario sometimes. So we're using something that we don't yet teach as a topic, and we're gonna teach it later. All right, but maybe you learned it already in an earlier class, or in an earlier, when you're younger. Pythagoras' theorem. And that's why I teach these basic things, in grade 7 and grade 8 and stuff. But basically, because that's a right angle triangle, if you want to find the length of that line AB using Pythagoras' theorem, then we're going to have to use that formula. Length of AB is going to be the square root of this length. Square root of this length squared plus this length squared. That is Pythagoras' theorem. All right? That is Pythagoras' theorem. That is Pythagoras' theorem that we're looking at. But if you notice, the xb minus the xa is really just the difference between the two x values. And the yb minus the ya, again, is just the difference between the two y values. So instead of memorizing it like that, we can instead write to the formula like that. And this is what I call, this is now a must-know formula. You need to know this formula. All right? Everybody would need to know this formula. This to be a must-know formula. That is actually a must-know that I'm writing, depending on doing what I want it to do, but that's what it is. A must-know formula. All right? Difference in y, difference in x squared, because the difference in the y value is squared. The square root of the difference in the x value is squared, because the difference in the y value is squared. That will give you the length of a line segment when you know the coordinates of the endpoints of the line segment. All right, so the only thing left to do now is just do an example. All right, so I want to do those two questions over on the right side here. So I'm going to find the length of the line segment AB, and I'm going to find the length of the line segment PQ over here. All right, so let's go. So I'm going to do this page for AB. I'm going to do another page for PQ. All right, so page 5. So I'm going to write the points now. So A is a point. A is a point. 1, 3. Mute your mic, please. Mute your mic. B is a point. 4, 7. All right, and I'm trying to find the line segment, the length of the line segment AB. So see here now, AB, the length of AB, and I can just write AB for the length of AB. The length of AB is equal to the square root of the difference in the two x values squared plus the difference in the two y values squared. I have the formula over on the left page, so I'm not going to write it again in yellow. So the difference in the x values, the x value of the B and the x value of the A. 4 minus 1, I have to remember to square it, because it's Pythagoras' theorem. Plus, don't be made a mistake and put a minus there all the time. Plus, the difference in the y values now is 7 minus 3 square. And I extend this because I want everything to be under the square root sign. That's gonna give me my length of my line. But understand that I could have also put 1 minus 4 and 3 minus 7, you know. I'm gonna get the same answer because the negative number squared and the positive number squared is the same. Right? So this would work out to be, this would then work out to be the square root of 3 squared plus 4 squared. And when you do trigonometry, you're going to learn about the Pythagorean triples, such that this works out actually to be 5. And because it's the length of a line you're finding, you must always give measurement a unit. In coordinate geometry, the unit of measurement in terms of distance is just units. The unit is just units. So the length of line segment is 5 units, 5 units long. But understand that so far? Just applying a formula. I'm going to get 5 because the 3 squared is 9, the 4 squared is 16, 9 and 16 is 25. The square root of the 25 is 5. So that answer there is 5, if you work it down. All right, let me go on the next page. Everybody can hear me good? But all right?
Yes, sir.
All right, cool.
Yes, sir.
All right, so let's go over here and do the next part. So I'm going to do P and Q now. So P is the point minus 3, 4. Remember, when you see all these negatives, now you get extra careful, right? And Q is the point 2, negative 6. You have to be careful when once you say those negatives. You're still taking the difference in the x values squared, difference in the y values squared. Watch this now. So PQ, the length of PQ, that means the length of PQ. If you want to write length PQ, you can write length PQ. Length of PQ is going to be square root, difference in the x values squared. So it's going to be 2 minus, that's this 2 over here, minus, I must have to minus that negative 3. So it becomes 2 minus negative 3 squared plus difference in the y value squared. So it's negative 6. That's this y value over here. Minus 4. Don't forget your square. And everything under the square root sign. That's that. And you care for the negatives and you work it down. So this becomes equal to now the square root of 5 squared, because 2 minus minus becomes a plus 5 squared, plus the minus 6 and the minus 4 is negative 10. Minus 6 minus 4 more is negative 10. So it becomes negative 10, and you're squaring that. And everything under the square root sign. All right? And then now, this becomes equal to the square root of 25. I'm going step by step with this one, you know. And the negative 10 squared now becomes a positive 100. So if you ever work in one of these questions and you end up with a negative number under here, like a negative 75, for example, something is wrong. You can't find the square root of a negative number. And at this level, they won't give you something like that to do. Right? That is for higher level maths, not your level. You deal with these things at a higher level, what we call complex numbers. Right? Not at CSEC. All right? And then this works out to be the square root, let me just write it here. Square root of 100, and in fact, let me write it below. It becomes the square root of 125. And remember, the unit of measurement is units. The unit of measurement is units. That's that. All right? But good so far?
Yes, sir.
Yes,
Yes, sir.
Dad.
All right, good. All right, this back. It was a 2. Right. All right. So that's the first thing. So just a formula, guys, to calculate length of a line when you know the 2 endpoints. Just remember, square root of the difference in the x value squared plus the difference in the y values squared. And when you have negative values in them, be careful with the negative values, as I did with this one. All right. Remember, when you square a negative number, it comes positive anyway. All right. So good. So let's move now to this one. Next thing. Midpoint of a line. So I want you right off the bat to think of a midpoint like an average point, a point in the middle, like an average point. The midpoint is a point that is halfway between 2 points. That's what we call a midpoint. So if you have a line segment, the midpoint of that line segment is the point that divides that line segment in 2 halves. So it's in the middle. So it's like an average point. And I'm telling you that now. Remember midpoint like an average point. Because the formula comes down to something simple like that. I'm not even going to spend too much time proving it here. All right? Because I want you to do that in C set. Was the average point. All right? And the calculation go like that. If you want to go and look back at it and figure it out, then basically that's what it comes down to. But bottom line, it comes down to that, which is XA plus XB divided by 2. That is the X value at the midpoint. And YA plus YB divided by 2 is the Y value at the midpoint. That's if the points are A and B. And we're calling that midpoint M. You can see that on the diagram. The midpoint of the line AB is the point M on the diagram. And the formula I want you to remember is this one. Easy formula. If you think of midpoint as an average point, then the coordinates of the midpoint of a line segment will be average of the 2 X values and the average of the 2 Y values. Average of the 2 X values will give you the X value at the midpoint. Average of the 2 Y values will give you the Y value at the midpoint. This is another must-know formula in yellow. Must-know formula in yellow. All right, so I'm going to do those 2 examples. All right, what I was saying is that this is a must-know formula. This is a must-know. All right, that's what the pen is giving me, so I'll just use it. That's a must-know formula, guys. And you have to know it. All right, you have to know that formula. All right, so let's do these 2 examples over here now. Let's do these 2 examples over here. All right, so I'm going back up to, it's the same 2 examples, A and the B. Same 2 points, A and the B again. So this is the A and the B that we had from before. We found the length. So this was the length that we did first. This was the length. Now I'm going to go for the midpoint. Down here now, midpoint. I'm just going to put the midpoint in our bracket. Put a capital M, meaning I'm calling midpoint M. And I'm going to do the calculation right there. It's so easy. Average of the 2 X values and average of the 2 Y values. Give you the coordinates of the midpoint. So the X coordinate at the midpoint is simply 1 plus 4 over 2. This 1 and this 4, average of those 2 X values. All right? That gives the midpoint. X value at midpoint. Comma. The Y value at midpoint now is the average of these 2 Y values. Average of those 2 Y values will give the Y value at the midpoint. And so it is the average of the 3 and the 7. Average of the 3 and the 7. Average them. Simple as that. And you work it out. Bam. This becomes 5 over 2. If you want to write 2.5, that's fine. That's the x value. And the y value becomes 10 over 2. 10 over 2, which is 5. Let me write the 10 over 2 so we can see it. 10 over 2, which is 5. If you like, you can write it as 2.55. You can write your midpoint as that, 2.55. Nice and easy. That's the midpoint of AB. Let's go down and do the midpoint of PQ. All right, let's look at it. So that is PQ. So this here was the length. This worked out to be the length. Mark doing this one thing. That was the length. And now I'm going to do the midpoint. All right, I'm going to do the midpoint now. So midpoint. And doing this one thing. All right, so for the midpoint now, I'm going to call it M again. M for midpoint, all right? Again, it's the average of the x values and the average of the y values. As simple as that. Average of the x values, average of the y values. The two x values are -3 and 2, and I average them. See here, the -3 and the 2. I average them to get the x value at the midpoint. All right? And the average of the y values is 4 and -6. 4 and -6 are the two y values I want to average. So it's 4. Now plus minus 6 is the same as just saying -6. If you want, you could write plus -6. But plus -6 is the same as just saying -6. All right? So you divide that by 2. And so that point becomes, this becomes -1, because -3 plus 2 is -1 over 2. And then 4 minus 6 is -2 over 2. So it reduces to, if you want to put decimals, -0.5, that's minus half. And it's going to become -1, because 2 over 2 is 1. That's a midpoint. So the midpoint is the average point. Remember, the length of the line is, like Pythagoras' theorem, square root of the difference in the x value squared plus the difference in the y value squared. Midpoint is your average point. Average of the x values, average of the y values. Simple as that. But it goes so far?
Yes, sir.
Yes, sir.
Yes, Dad.
All right, nice. So now we're gonna go and look at gradient. Gradient, what is gradient? Gradient really is just a measure of slope, how steep a line is. All right, that's what gradient is. And it also kind of indicates somewhat direction. So let me just go and show you what I mean a little bit. So let's say I have two lines. Let's say I have two lines. I'm going to draw two lines. Starting here, draw a line there. I'm going to draw a second line here. All right. Now, which of those two lines is steeper? Let me use two different colors so you can respond to me with respect to the colors. So I'm going to draw another line in red. All right. So, so I'm going to draw another line there. Good. So which of those two lines steeper? The purple one or the red one?
Purple.
Purple.
And therefore the purple one has a higher gradient, it has a higher slope. If you drive, just imagine you're driving a car up the purple one. Then you feel like you're falling off even more than on the red one, right? It's a harder climb, it's a higher gradient. How you measure it, how you actually do the measurement? What you do, you measure the vertical that you cover in relation to the horizontal that you cover. It's the ratio that you take. The vertical from one point to the next, so in the red line is from this point to this point. How much vertical you get in comparison to the horizontal. In the case of the purple one, it's a similar thing. From this point to this point, how much vertical you get in relation to the horizontal. Now, if I use the black for the horizontal, I'm trying to make the two of them have the same horizontal in this example, right? Just to illustrate the point. Right? So, if you look at it, for the same horizontal distance, and horizontal distance is a change in x. So that's a change in x. I can say a difference in x. Right? This one, the purple one, you cover more vertical than for this one. For the same horizontal, you cover more vertical. So if you want to measure gradient, you can't just use the vertical alone. You have to do it in relation to the horizontal that you have covered. And that is why they say gradient is how much you rise divided by how much you run. So down here is the run, and up here is the rise. So if the run is the same, then the one with the higher rise therefore has a higher gradient if the run is the same. So that is why when you're taking gradient, you do it rise divided by a run. You can't use just the rise alone, you can't use just the run alone. It is in relation to the run, how much you go across. All right? So it is how much vertical you get in relation to how much horizontal you get. Simply put, it is rise over run. But because we're doing it with coordinate geometry, you have to go and get some numbers, because what will happen is that these points will have coordinates, x and y coordinates, all these points. And you can measure the gradient using those coordinates. All right, so let's get into it now. So gradient of a line, and the gradient of a line in coordinate geometry, the symbol is common M. Capital M is for a midpoint, common M is for gradient. It's a symbol that is used for gradient. All right, I don't know why they don't use G. I think they use G for something else. All right. I know G is used for gravity in physics, so I guess maybe it comes from that as well. But M is used for gradient. All right, and it is a measure of slope, and it also implies direction, because back on the graph here, we can say this line going in that direction on the paper, while this one going in this direction on the paper. So there's also kind of an indication of direction. All right, and that's how you calculate it. It is given by the change in y, which is the rise, divided by the change in x, which is the run, from one point to another point on the line. So it has to be between points when you have a line. When you have a curve, it's a different thing. All right, now we deal with curve at a later date. The concept is a little bit different. All right, but we'll deal with that, right? Because we're focusing on line. So we're talking about the line. It's from one point on the line to another point on the line. You measure the change in y, which is called a rise, and you divide that by the change in x, which is called a run. And so that's what we get. Gradient is rise over run along a line. So basically from one point to another point. And you can use any 2 points on a line to measure the gradient. Any 2 points can be used. So if it's a straight line, the gradient between the two endpoints will be the same as the gradient between 2 points in the middle of the line. Once those points are on the line, you can use any 2 points. And that is important, guys, for you to remember. Because sometimes students have the information in front of them that they can use, and because they don't know little things like this, they don't move forward. You can use any 2 points once you know the coordinates exactly. Once you know the coordinates of those points precisely and exactly, you know that these points are actually on the line. You can use any 2 actual points on the line to calculate the gradient by doing the change in y over the change in x. And the change in y really is a difference in the y values from one point to another point. And the change in x really is a difference in the two x values from one point to another point. All right, and that is it. So if you have those points there, A and B, then from A to B, we're thinking about from A to B, the run is the x value at B minus x value at A. That is xb minus xa. And the rise is the y value at B minus the y value at A. That is the yb minus ya under the rise. And those are the values that we want to use to calculate it. We're going to take the ratio, the rise over the run. And so we get that. Yb minus ya divided by xb minus xa. Some teachers use 1 and 2, y2 minus y1 and all these things. I want to point out something to you that is very important right now before we even move forward. All right? Right here. If when you're calculating a gradient, you start with B up here, you also have to start with B down here. In other words, if you do yb minus ya, you have to do xb minus xa. You cannot change it around. Notice here, I'm using starting with the point A. I'm using ya over here. So because I'm using ya there, I have to use xa right here. So it has to start with xa. So if it is yb minus ya, it has to be xb minus xa. If it is ya minus yb, it has to be xa minus xb. You have to choose the direction. Remember, you know, gradient is a matter of direction. Because you can have a positive gradient and a negative gradient, you know, and they mean different. They mean something different. Positive gradient, negative gradient. I'm going to deal with that soon. What they mean, the difference. But I wanted to point that out first. So if you do yb minus ya, you have to do xb minus xa. If you do ya minus yb, you have to do xa minus xb. You cannot do yb minus ya and then do xa minus xb. No, you're going to get the wrong answer. You're going to get a negative when it's supposed to be positive, or you're going to get a positive when it's supposed to be negative. All right? So let's go. All right. Bam. So it comes down to that simple formula. Difference in y over difference in x, provided that the direction you take for the difference in y use the same direction for the difference in x. That is the only caveat in this formula. You cannot just randomly choose the difference. When you're doing the length of the line, because you're going to square the values, it don't make any difference. But when it comes to gradient, because gradient now has a direction component to it, you have to do the same direction for the difference in y as you do for the difference in x. All right? I'm going to show you an example. So this is another must-know formula, guys. You must know this formula as well. So this is another must-know formula. So let me write it up here. And if I zoom it up and then write it, it's a little better. Let's see. Let's see. You can do everything that I don't want it to do. This is what I want. And it's not moving now. I'm still learning to use these things, guys. Remember, I know I used to teach in the classroom all the days of our life. And then COVID, so you have to go and teach online. So I have to learn to use all these things I know I used to use before. All right, so this is another must know. Another must know formula there. The one in yellow. Easy way to remember the gradient. Difference in y over difference in x. So the difference in the two y values divided by the difference in the two x values will give you the gradient. The only thing, as I said, to remember is that the direction you go when you take in the difference in y, you must go the same direction when you take in the difference in x. All right, that's all you need to remember. Difference in y over difference in x. All right. Let's erase this now. All right, let's make it smaller. Good. All right, so I'm gonna do these two examples again. The same two that we're working with, same 2 points we're working with. So let me go and find those two. See them here? That is A and B. So I can do it right here, A and B. All right. So now I'm gonna find a gradient down here now. Gradient. Gradient. Let's go back for the purple. Gradient. Do the wrong thing again. All right, so we're doing gradient now. Gradient. And the symbol for gradient, as I said, is M. All right, so we're doing the gradient of AB now. So I'm going to write M subscript AB. Say I'm finding the gradient of the line AB. All right, and that equals, I have the formula over there, so I'm not going to write the formula. I'm going to take the difference in Y over the difference in X. Now let's say I'm doing the B point minus the A point. Remember, you know, when the gradient, you have to choose which point minus which point. You know. So if I'm using the B point minus the A point, then it's going to be this Y value minus this Y value. Difference in the Y values. All right? You have to make sure. And plenty of people have the mistake of putting the difference in the X values and the numerator all the time. Try not to make that mistake. It is rise over run. Rise is the difference between two Y values. Two Y values. So it's we're gonna use 7 minus 3 divided by. Now because I started with the B point on the numerator, I have to go back and use the BX value on the denominator now. So I have to do the 4 minus the 1. I cannot randomly put 1 minus 4 now. Because I did the 7, which is the B value, minus the 3, which is the A value. I have to use the 4, which is the B value, minus the 1, which is the A value. So my denominator is now going to be 4 minus 1. And that works out easily to 4. That works out nicely to 4 over 3. 4 over 3. Now let me show you that I could have gone the other way as well and get the same answer. So I say or. If I was going the other way. Or. I could have used instead the A value minus the B value. So in that case, I would be doing this Y value minus this Y value. I was doing the A point minus the B point. Answer is going to be the same. All right, look. So in that case, it will be instead 3 minus 7. But because I started with the A value when I'm taking the difference in Y, I have to use the A value now minus this one when I'm taking the difference in X. Since I start with the A value for the difference in Y, I have to start with the A value for the difference in X. So it's going to be 1 minus 4. And what will happen here now is that you will simply get negative 4 over negative 3, and the negative would cancel each other, and then this would still come back to the same 4 over 3 that we had up the top here. Well, understand that?
Yes,
Very good?
Sir.
All right.
Yes,
All
sir.
right. Let's go and do the P and the Q now. We have some negatives in it. I have to be careful with these negatives now. Let's go and do the P and the Q. All right? Nice and easy. Soft. All right. So let me get another page. I think I'm supposed to be able to copy that thing, but all right. Let me wonder if I can fit it right here. Let's see if I can fit it right here, the P and the Q. All right. Let me just write them back on another page. Just go on another page and let's write them. Let's go on another page and let's write the P and the Q. All right. Let's just rewrite them here. So, all right. So what was the P again? The P is the P. This thing doing all kind of things. Not me doing all of that, you know. The P is negative 3, 4, and the Q is 2, negative 6. And I'm trying to find the gradient, right? I'm trying to find the gradient of PQ. This is common M PQ. Always common M for gradient. Common M PQ. The PQ there just means that I'm finding the gradient of PQ. All right. Write it better. All right, ready now. So it's difference in Y over difference in X. So again, let's say I'm using this point first minus this point minus this point. Let's say I'm doing that. That point minus that point. What would that mean? It will be -6 minus 4 divided by difference in the X values now. Since I started with this Y from this point, I have to start now with the 2 from the same point. So I have to go and say 2 minus this -3. Difference in the 2X values now. The same direction, the difference in 2Y values. So it will be 2 minus, and that is now -3. So they come into play now. It's not just 2 minus 3 now, it's 2 minus, and that X value is -3. And so this becomes -10 on the numerator over minus becomes 5 because the minus is a plus. So we get 5 on the denominator. And that works out now to -2. -2. Can I write it? -2. Can I write it? It's not allowing me to write anything over there. So we put under here. So this works out now to -2. That is the gradient. All right? Or if I get the other way, and you don't have to do it both ways, and I'm just doing it both ways to show you that any direction you go when you're taking the difference in the Y value, you must go the same direction for the difference in the X value. Everything important. Or I could go the other way and do the P point minus the Q point. So let's say I'm going the other way. Or my gradient of PQ would be this Y value minus this Y value. I'm doing the P point now first minus the Q point. P point minus Q point. So it will be 4 minus, and then that Y value now is -6 divided by, I have to now use this X value minus this X value because I'm using the P point minus the Q point for the difference in the values. And so it will be -3 minus 2. -3 minus 2. That's what we will get. And then this will work out to what now? The minus in here is a plus. So that is really 4 plus 6, which is 10. Divided by -3 and -2 under there now is -5. It's the same thing. 10 divided by -5 is -2. -2. And that's it. That's it. I'm gonna try a different pen. This pen giving me some problems. So I'm gonna try a different one. Let's see if I get any improvement. If I don't get any improvement, I'll come back to this one. Let's try another pen. Let's see. So far, so good? Very good so far?
Yes, sir.
Yes, sir.
Yes, sir.
All right, cool. So that is gradient, guys. All right. So moving on to the next thing now. Which is, all right. So that is the other pen. Just wrote that. So let's see how that one works. All right. So moving on to the next. Oh, the sign of gradient. Yes, sign of gradient. Very important. That has to do now. You're supposed to be able to look at a line and know if it has a positive gradient or a negative gradient. So let me show you over here before we even go to the slide. Very, very simple. So let me just show you over here first. Now, You must always think of a line as if you're going from left to right. Always. If I draw a line like this, right? Draw a line like that. Think of it as if you're going from left to right along the line this way. Always think of it as if you're going from left to right. And at that line, if I'm going from left to right, I'm generally going up. If you're generally going up, it means that you have a positive gradient. A positive gradient. So this is not writing so good. See, this is not writing good. I need to find something. Positive gradient. If I'm going up. If I have a line sloping this way, and think of it as if you're going from left to right. See it this way. Then you're generally going down on this line. And when you're going down, you have a negative gradient. A negative gradient. So line sloping up from left to right, positive gradient. Line sloping down from left to right, negative gradient. Always think of this as if you're going from left to right. So what if it is not going up nor down? It's going straight across. Bam. Straight across. It's going straight across, is neither going up nor down. So the gradient is not positive and it is not negative. So if it's not positive and not negative, what is it? Not positive and not negative. What is it? What? Neutral, right? Which is what? It's what? What will be the value of the gradient if the line is just horizontal? Zero. Exactly. If the value is not positive and not negative, then it is zero. Not going up or not going up or it's just flat. A flat line. So this is zero gradient. It's zero. This pen not working so good either. It's hard to find a good status. I'll keep searching. Zero gradient, that line. All right. Question though, what if the line is vertical like this? Bam. What happens then? What do you think the gradient would be? Vertical, steep. What about the gradient? Nope. Have two different. Let me tell you something. Mathematics is the most exact science. Two different things can't be the same thing. Alright? Nope. The gradient will be zero, would be infinity. Infinitely large gradient. So steep it can't measure it. So the gradient for this vertical line is infinity. I'm gonna show you why just now. Over on the slide. I can show you right here now. Remember the gradient is rise over running. So if we go from this point to this point, there's a rise. But what is a run? Gradient is rise over run. A run is the horizontal distance that you go. What is a run if you go from this point to this point? What is a run?
Zero.
Zero. So you divide them by zero, don't you? So the sum value over zero. And what did we say? Whenever you divide by zero, you're undefined. So the quantity is the gradient is infinitely large or undefined when it is vertical. All right. In the case of this line, the rise is zero. From this point to this point, there is zero rise, no rise. But there exists a run. So the run is a value. Zero divided by a number is just zero. That's for that line. So the vertical line has an undefined gradient. It's infinitely large. Right? Past steep. Alright? So we'll come back on the slide over here now, the sign of gradient. And basically look at the slide. It's what I just explained over on the right side here. So line sloping up like that, positive gradient. You're supposed to look. So we're doing a calculation with a line like that. And the gradient come out negative. You know, say you make a mistake. You don't make no sense you continue. You have made a mistake. Alright? Bam. Start line sloping down. Going from left to right along that line, you'll be going downwards. Negative gradient. You're falling down. You're going down. Falling down. That's a negative gradient. Going from left to right. Horizontal line, zero gradient because there's no rise. So the gradient is zero. Flat. Just think of driving on. Mute your mic, please. Mute your mic. zero gradient. And then for vertical line, as I said, the gradient is undefined because you have to divide by 0. All right, so you have to be able to look at lines and know the gradient. And they ask these things in CXC, you know. They give you a line and they give you some values for the gradient, and you're not calculating anything. You're supposed to look and know, so okay, the line sloping upward is a positive gradient. And sloping upwards means from left to right. The line sloping downwards from left to right, then it's a negative gradient. If the line flat, not going up at all, then the gradient is 0. If the line vertical, then the gradient is undefined or infinitely large. All right, moving along. Equation of lines now. So, equation of lines. Now, what's the equation of a line? The equation of a line is basically a relationship between the relationship connecting the x and y values for points on the line. That's what it is. So for a given x value, you can use that equation to work out the corresponding y value for points on the line. That's all that it is, an equation of a line, isn't it? It's an equation connecting the x and the y value, x and the y values at points on the line. That's what it is. All right. Now there are two basic forms. There are more than two, but there are two basic main forms that you're going to be using at CSEC. One of them, to me, is far more useful than the next. But the one that is far more useful, I feel like not a lot of teachers emphasize that one. Right? They tend to stick to the y equals mx plus c, which is what everybody learns first for the equation of a line. All right, but the other one is a BFF, really. So this is the first one, the y equals mx plus c. And to derive the equation of a line, the formula for the equation of a line, they set up this thing that we're looking at here, right? So if you look here on this diagram, this is the known point. It's a y-axis intercept. So you know that point. So you say, okay, this line crosses the y-axis at a point 0, c. Now see this point up here that they call xy, it's called a general point. That point basically is used to represent all points on the line. It's used to represent all points on the line. So when you get an equation connecting the x and the y value, because that point is a general point representing all points on the line, then that equation connecting the x and the y will be valid for all points on the line. And then now, this is the gradient, m. So we're going to be using these letters. We're going to be using x and y representing general points. We're going to be using m for the gradient, and we're going to be using c, which is the y-axis intercept. But to derive the formula, we'll come back to the basic way of finding gradient, which is to say gradient is the difference in the y values over the difference in the x values. And that is how it is done. All right? See there, the gradient m is the difference in the y values divided by the difference in the x values. And so it is this y value on the general point minus this y value on the y-axis intercept. And then you divide that by this x value minus this 0 on the y-axis intercept. So the difference in y by difference in x just the same that we just did. That's what it is. And then the x minus 0 is just x. And so we end up with that. Right? We end up with that. And then when you simplify it, so we end up with that now. When we simplify it, transpose the x, we get mx equals y minus c. And then if you care about the c, you get the mx plus c equals y, which is the same as saying y equals mx plus c. All right? And this is what they call the standard form for the equation of a line. And this is what most people use. Most people at this level use this, at C-set level. They use y equals mx plus c. M is the gradient, and c is the y-axis intercept. The point, the y value at the point where the line intersects the y-axis. And note as well that when you have y equals mx plus c, such that m is a gradient that c is the y-axis intercept, y alone must be the subject. Y by itself, right here. Y by itself is a subject. Not 2y, not 3y, not 4y. Just y by itself must be the subject in order for the m in front of the x to be the gradient and the constant to be the y-axis intercept. Pay attention to those details from now. All right? So let's talk about the standard form now. Let's talk about the standard form. So this is called a standard form, or it's called a gradient intercept form, because it has a gradient in it and it has the intercept, the y-axis intercept in it. All right, so this is the gradient intercept form, which is also called a standard form for the equation of a line. All right, m is the gradient, c is the y-axis intercept of the line. All right, and you basically use this formula to find the equation of a line when you know the gradient and you also know the y-axis intercept. Now, persons use it when you don't know them, you know, but I'm teaching you to use it when you know those two, because I'm going to teach you another way when you don't know the y-axis intercept. All right, I'm going to summarize everything that I'm saying. All right, so let's look at this now. This example. Fairly simple, straightforward, this one, because for this one, we know they give it a gradient, which is 2, and they give it a y-axis intercept, which is -3. And the equation of a line is y equals mx plus c when you know the m and you also know the c. And so that equation is simply y equals 2x. And the plus c is -3. So you can just write -3 right there. And the plus c is -3. And you're done. Easy, straightforward. But see, I never give you something as simple as that to do. When they must give it a gradient and they give it a y-axis intercept. They do it sometimes, but hardly. Right? They might give you a multiple choice, for example, for 1 mark. But they're ever gonna give you. If they even give you that, it's just 1 mark for it. If they give you that to do. So easy. What they'll more likely require you to do is to use the other form, which is over here now. In this case now, you have a line with a gradient of m, and you have a known point. You don't have the y-axis intercept, you know, but you have a known point on the line, meaning you know a point on the line. That known, what we mean by known point? Known point means you know the x value and you also know the y value at that point. You know, so the x value, for example, is 2 and the y value is -5. You know the values. And you also know the gradient. You know, so the gradient, for example, is 3. When you have that information, you are able to find the equation of that line using another form, which we call now the point gradient form. And to derive that formula, again, let me break this down a little bit more so we can understand it, right? So in this form that we're looking at now, this now is your known point. So you know the xp and you know the yp. So xp and yp represent the known point, P. Now remember, you don't have to call it P, you can call it Q. So if it was Q, it will be XQ, YQ. If it is R, it will be XR, YR. If it was M, it will be XM, YM. All right? So that in any case, that is a known point. And again, this now up here is a general point. It represents all points on the graph. That's a general point. XY is a general point. So when you get a formula connecting XY and connecting XP, YP, and the gradient, the XY now will basically represent all points on the line, every point on the line, the X and the Y. All right, because the M would be known, the XP would be known, and the YP would be known. And it's giving you now a relationship between X and Y for points on the line. All right, and it comes back again to prove this formula now that we're going to look at now. It comes back to the gradient business. We know that gradient is rise or run, difference in y by difference in x. So that's what we have there. The gradient is going to be this y value, minus this y value. That's going to, I'm going to divide that by this x value minus this x value. All right, that's what we're using. So, bam. When we multiply now across, that's what we end up with. Look at it. All right, if we multiply this denominator over this side by the m, we're going to get this, m times that. And then this is going to be left on the right side, but we'll just flip it around to show it like that. And so that now is my BFF, best friend forever, when it comes to finding the equation of a line, because it works once you know the gradient and any point, even if you know the y-axis intercept. But we have the y-axis intercept, you don't want to waste time and use this enough. But CXC more than likely will give you one where you have to use this. So you don't have to use this, but where this is the BFF to use, best friend forever, for the equation of a line, BFF formula. Y minus the y value at the known point equals the gradient into x minus the x value at the known point. You will use this formula when you do add maths. You will use this formula when you do pure maths. You'll use this formula when you do unit 1, when you do unit 2. And if you want the further maths, you'll use this formula as well. This is a BFF formula for finding the equation of a line at any level of maths that you want to do. So better just learn from now and down and get used to it and get comfortable with it, and that's BFF it like me from now. All right, so my BFF is your BFF when it comes to finding the equation of a line. But good, but I agree with that.
Yes, sir.
Good.
Yes, sir.
Lovely, I like that. All right, so let's move on. I'm gonna look how we use it. So this is called a gradient point form, because we're gonna use this form. You need to know the gradient, and you also need to know a point on the line. That's why we call it the gradient point form for the equation of a line. It uses the gradient and a known point to get the equation. All right, and most of the questions will be set up for you to be able to use this one. Most of the questions, they hardly will give you one in CXC where the y equals mx plus c as I teach. And no other teachers teach you to use y equals mx plus c and still use a known point, where they make you calculate the c different, But I don't like that method. It's too much work. We can just use this BFF and do it. Do the maths like big people, like in first form. All right? Let's go. It's on the syllabus as well. I'm not giving you something that's not in the syllabus. This is on the syllabus as well, so use it. Just that a lot of teachers don't spend a lot of time teaching this one. They tend to just stick to the y equals mx plus c. All right, but we have to graduate and learn new stuff and do the math like big people. All right, not like we in first form. All right, so m is a gradient, guys. XP is the x value at the known point. So remember, this is one where you have a known point. So XP is the x value at the known point. YP is the y value at the same known point. So you can't use the x value from one point and use a y value from a different point. You have to have one known point. A known point, any known point. So you choose whichever known point that you have. So if you have 10 points on the line, you choose one of the points, then you know the x and the y value. Any known point. If you have one known point alone and the gradient, you're good. You can still find the equation. So you use a known point. So I make sure say at the same known point. So you can't use a y value from a different known point. All right? And so we're going to do this example on the right side of the page. So we're talking about a line where the gradient is 2 and the known point is r, 3, 5. So let me look and show you. Let me show you how you use these values now for the equation. All right. And we can maybe even go back and use it for the two examples that we did earlier, the A and the B. All right, and I'll show you. So I'm talking about a line. I'm going to find the equation of a line. Equation of a line where the gradient is what I'm saying, 2. Oh Lord, not me doing all of that, doing it one thing. Gradient is 2 and That's M is the gradient and the known point. Known point is R. And the values in that known point are 3 and 5. Like that. Boom bang. That equation is simply y minus, the known point is r, so I want to call it yr, equals the gradient into x minus the known point is r, so I'm calling it x. Since it's p, I will use over there on the left side in yellow, and I use r because I know that the point is r. So it becomes y minus the y value at r now is what? Y value at r, let me mark them for you. The y value at r is coming here. And the x value at r is going there. Simple as that. All right? So I'm going to go back for the purple now. Bam. So it becomes y minus 5, the y value at r, equals the gradient, which is 2, into x minus the x value at r is 3. And I can still get my c from this, you know. When we simplify it down in the form y equals mx plus c, I can still get my c. Watch this now. I'm going to expand it out first, the right side. So it becomes y minus 5 equals 2x minus 6. And then I carry this negative 5 over here and turn it into positive 5. Right? Carry that negative 5, turn it into positive 5. I'm going to get y equals 2x. And then the negative 6 plus 5 is negative 1. So it means that my c value is negative 1. So I still know my c value from there because I now have y alone as a subject. And when you have y alone as a subject, this is your gradient. So I see my m there. That is my m. And then now this is my c. That is my c. It means that this line crosses the y-axis at the point 0, negative 1. But that's my c value is negative 1. But understand that? But good there?
Yes, Dad.
No, sir. Can you go
Nice.
back one more time, please?
Go over it one more time. We basically just using the formula. All right. Let me. I'm not going to go over this one. I'm going to do another example. And you follow. Cool? Let me do another example. Let's do another example with some negatives and stuff. All right. So let's go back. Let's go back and do another example. It's the same procedure. Even with another example. All right. So remember this line that we were working on earlier with the P and the Q? I'm going to do it I'm going to use the 2 points with the gradient and show that the equation is going to be the same. All right? That's what I'm going to do. And show that any point and the gradient. So let me use a different color for this part. All right, let's use a red. So I'm going to find the equation down here now. Equation. So I'm finding the equation of the line PQ. Equation of PQ, the line PQ. Now let's say I'm using the point P. I'm using the point P. Now remember, the gradient, the gradient of PQ, I have it already, is negative 2 right here. See there? Negative 2. So we have the gradient of PQ. Let's write down here again. The gradient of PQ is negative 2. So that is the gradient that we're going to use. Use the gradient of the line that you want. All right, and use a point on the line that you want. So the equation of using the point P is going to be y minus yp. Y minus yp equals the gradient of PQ into x minus xp. That's what we're going to have. Y minus yp equals the gradient of the line PQ into x minus xp. That's a formula. We're just plugging in values in this formula now. That's all you know. So the point P here that we're using up here, right? Let me mark it for you. This is YP. Why will that P? And this is XP. That is XP. I think not allow me to write it properly, but that is XP. Right? So it becomes Y minus the YP value is 4 equals the gradient, which is negative 2, into X minus, watch this now. The X value up there is negative 3. So it's X minus and negative 3. And the minus in here now becomes a plus. Right? So it's going to become Y minus 4 equals negative 2 into X plus 3 now. And you can expand this out. So you're going to get Y minus 4 equals minus 2X plus, no, not plus, minus. As minus 2 times plus 3 is minus 6. What happens next? Simple. This negative 4 goes over this side, become positive 4. All right, and then we're going to get Y alone equals negative 2X. Then the minus 6 plus the 4 is minus 2. That is it. Minus 2. Good? So remember that formula now. Y equals, I'm going to do it again now on the next page, right? I'm going to do it with this point next. I'm going to do it with that point next.
Excuse me, sir.
Right, so yeah?
You brought over the 4 and take away.
Yeah, because when you come over, you go come negative 4, negative 6 plus 4, and you come over. Now go and give me this negative 2 right here. So. See that?
All right, sir. Yes, sir.
All right, cool. All right, let's do it again. So I'm going to get same equation using the point Q, but I'll do it on another page, right? This page 4. So let's do it on another page now. All right, so let's do it on another page. Let's go down and do it on another page. Where's the page thing? All right. All right, you can clear this out. Clear out this page. All right, watch this now. So remember the point Q was what? Let's look back at it. The point Q is 2, negative 6. So the point Q for the next example, using the point Q now. So the gradient of PQ, remember, is negative 2. And we're now using the point Q, which is 2, 6, we say? 2, negative 6. 2, negative 6. 2, negative 6. I'll get the equation a while ago. Negative 2x minus 2. Y equals negative 2x minus 2, right? So in this case now, we're getting an equation using the point Q. Consider the same line, same equation. It's going to be y minus yq equals the gradient of the same line PQ into x minus xq. All right, let's look at the details now. Let's look at the details. These are different color, so I can show you the details. All right. So this value is my YQ, and this value is my XQ. See that? XQ and YQ. So those are the YQ coming here and XQ going there. Those values. So let's go back now. All right, and do it. So I get Y minus YQ is negative 6 equals the gradient is negative 2. That don't change. Bracket X minus the X value now at Q is 2. That is it. And now work it out again. So this minus over here now becomes a plus. Right? It becomes a plus. So it becomes Y plus 6 equals, I'm going to expand this now. So I'm going to expand this now, I get negative 2x, but I'm going to get plus 4. By the time I get plus 4, the minus 2 times the minus 2 give me plus 4.
Yes, sir.
Good. And then what will happen is that this positive 6 come over here, so it'll become minus 6. Right? Come minus 6. So I'm going to get y alone equals minus 2x. And then when I carry over the 6, I'm going to minus 6. I get negative 2. Right? 4 minus 6 is negative 2. So I get minus 2. Same thing I get using the point Q. So I did it over the first page, over here, using the point P. I get the equation here. So I'm going to use the point Q over the next page. Here, so get the same equation. That proves it. Understand it better now, boss? Who do you want me to do it over?
Yes, sir.
Good. Soft. These things are. Just need to practice, guys. Soft. All right? So that is how you find the equation of a line. But let's summarize. Let's summarize what all that we have said about the equation. This thing is very important enough. So I'm going to make some statements now that you need to remember. Put it in a brain. Make it stick. All right? Summarizing. When we want to find the equation of a line, there are two things about that line we must know. So that is the two you're gonna ask yourself. If you're doing a question and the question says, find the equation of this line. You're gonna ask yourself two things. Two things you must know. One, you must know the gradient of that line. See, if they don't give you the gradient, they have to give you some information for you to find the gradient. They might tell you, say, parallel to another line. You can use that information to find the gradient. They might tell you, say, it is perpendicular to another line. You can use some information, that information to find the gradient. Or they might tell you 2 points that it passed through. If they tell you 2 points that it passed through, you can use the difference in y by difference in x from those 2 points and find the gradient. But in any case, you must know the gradient. The second thing that you must know is a known point. You must have a known point if you're going to find the equation. Now, if they don't give you a known point directly, they must give you some information that you can use to find that known point. They might tell you that it is a point of intersection of two lines. They might tell you, they can tell you anything for you to find that known point. But at the CXC level, most times they just give you the point. What they like to do at the CSEC level is give you the point, and then for you to find the gradient, they give you something, some information for you to find the gradient. They have to work out the gradient, and they give you the point most times at CSEC. But in any case, if you want to find the equation, you must know them two things here about the line. First, can't find the equation unless you know those things first. That's what you're looking for if they ever ask you to find the equation of a line. The first thing you must know is the gradient. If they don't give it to you, they must give you some information to find it. The second thing you must know is a point, where you know the x and the y value, a known point. If they don't give it to you, a known point, they must give you some information for you to find the known point. That is the basis of finding the equation of a line. And if you approach it that way, you won't have any problems. All right? Now, sometimes the known point will be the y-axis intercept. And when the known point is the y-axis intercept, just drop the gradient and the y-axis intercept, and you have the equation straight. But guess what? If CXC set the equation of a line 50 times, maybe only one time, then I'll give it to you where you just use this alone and done. Right? Right? 49 out of the 50 times, the BFF can be used. Now, this can be used other times too, you know, but I'm not teaching you to use it that way. I don't think I'm teaching it that way. If you learn it that other way somewhere else, fine. You can use it if you want. Just make sure that when you do it, you get it right. I'm teaching it the way that I want you to use it, because I want you to get comfortable with the BFF formula. I want you to get comfortable with it because But they're comfortable with things at this level that you're going to use at the higher level anyway. So let's get comfortable with it from now. So every time I'm doing a question where they give you a known point and a gradient, and where that known point is not the y-axis intercept, I'm going to be using the BFF. The only time you'll see me use y equals mx plus c is when they give me the y-axis intercept with the c straight. That's the only time. All right? So learn that from now. So this other method now is when they give you a known point that is not the y-axis intercept. Then you use the BFF, as I just did in those two examples a while ago. All right? So in summary, to find the equation of a line, you must know two things. This is what I wanted to remember. To find the equation of a line, you must know two things about that line. You must know the gradient of that line that you want, and you must have a known point on that line that you want. If the known point is a y-axis intercept, they really not do no work. You just put it in the form. You just put it in a formula that is y equals mx plus c, because the m is the gradient, and the c value at the y-axis intercept, the y value at the y-axis intercept is your c value, and you just drop those values in and you're done. If the known point is not the y-axis intercept, like a point like 3, a point like maybe 3, -4 is your known point, then you have to use the BFF right here. Y minus, and then this will be your known point, P. And we just did an example and we call it R. And we did an example when the point is Q. And we did an example when the point is P. Whatever the point is, you call that point. We just use the P in the formula to teach it. It's not always going to be the point P. It can be any point, any letter. But we just use P for teaching the topic. All right? So in this example, this one would use the BFF clearly. Because this is the known point. I'm not going to do that one here now, because we just took up examples a while ago. I can maybe just start it and show you. And this is the M right here. So let me clear the screen and show you the examples. So let's say we're doing this one first. This one first. Let me do it over here quickly, because we don't need to waste no time on this now. All right? For that example, let's start at example 1. For example 1, it will be y minus ya, A is a point, equals the gradient into x minus xa, because A is a point. And so it will be y minus the ya will be 3, but you can say that, equals the gradient is -2 that they gave us, bracket x minus the x value is -1. That will be it. Then the minus in the bracket is a plus. So it will be y minus 3 equals the -2 gradient into x plus 1. Minus is a plus. Let me expand this now. Expand that. So it becomes y minus 3 equals -2x minus 2. Then this -3 coming over here to become a +3. So we're going to get +3 minus 2 on the right. 3 minus 2 is 1. So it's going to simply become y equals minus 2x plus 1. So we know the y-axis intercept is +1. 0 plus 1 is the y-axis intercept, 0, 1. Right? So that is the first one. The second one over here now. Easy. 2. Easy. Soft. 2. Hold on again. Secure the second one now. Nice and easy stuff. Second one. Find the equation of a line passing through the origin. Pass through the origin. The origin is a point on the y-axis, so the c value is 0. The origin is a point on the y-axis, C value is 0. The gradient is a half. The gradient is 0.5 or a half. So if you know the C and you know the gradient, you go just use the y equals mx plus c, to get the line. The C is 0 and the m is 0.5. So this becomes y equals 0.5x. Done. In fact, Any line passing through the origin, any line through the origin, because the C value at the origin is 0, will always have the form y equals mx, because the C value is 0. Once a line passes through the origin, the equation is just y equals mx, because the C value is 0. Any line passing through the origin. Line through origin, let's call it origin lines. Let's call them origin lines, meaning line passing through the origin. Right? Lines through origin will always have this format here. Y equals mx. Why? Because the C value will always be 0. That's why that one is y equals 0.5x by pass through the origin. Everybody good? Understand that?
Yes, sir.
Yes, Dad.
Nice.
Yes, sir.
Good. All right. So moving on now. Something else. How long we going now? How long we going now? I mean, teach all day and I stop, you know. Now, stop me sometimes, you know. What time
2
is it now?
hours.
Gone 2 hours?
Yes,
All
Dad.
right. All right. I did want us to do parallel and perpendicular lines today. And I wonder if we can just do it fast. Let me see. I think that is what coming up next. Let me see. That is what is next on the slide, you know. Oh, find equation of a line from a graph. All right. Let me see what's coming after this. Let's slide through quickly. Let me read equation of a line. And then, all right. So we're going to stop at parallel and perpendicular. Let's do this last 2 things and then we'll start back tomorrow. Parallel and perpendicular lines, right? All right, let's do reading the equation of a line and then the equation of a line from a graph. And then we'll stop it for today. All right, and then we'll start back tomorrow with the parallel and perpendicular lines. All right, so this is now finding the equation of a line from a graph. Now, the reason I did this slide is because I've seen in the past where CXC, they like to give questions where they give you a line on a graph. They give you the graph and they show the line on the graph. And then you are supposed to look at that line on the graph and find the equation of that line based on the points that the line passed through. Based on the point that the line passed through, right? So when that happens, what they like to do, they like to also put a point on the line that you don't know for certain what the coordinates are. Or they indicate 2 points whereby one of those points you don't know the coordinates exactly, and that's why I created this slide to cover that. Right? So it's not like we're really learning anything brand new, but it's just to cover something that CXC like to set in exams. All right, so let's look at it. So the method is to locate 2 exact, and the key word here is exact, 2 exact points. So you can't use a point where you have to be estimating the values and say, all right, this point will look like 3.3, you know, and the point will look like 3.5, you know, but you're not sure. Locate 2 points where you know for sure. So 2 exact points you want on the line. So you're gonna look at the graph, you know, and locate 2 points that you know for sure. 2 exact points that you know for sure. That's what you want, right? And then you use those 2 points to find a gradient. So after you find those 2 exact points, you use them. Use those 2 points to find a gradient. And we know how we do that already, right? We know how we do that already. All right? We know how we do that already. So you use them to find a gradient. 2 exact points. Difference in y by difference in x. Okay, I forget that, you know. I know it's today we did it, but you have to remember. All right? Difference in y over difference in x. Using 2 known points. After you find the gradient, remember, you use that gradient now with any one of the 2 points and drop them in the BFF formula. The BFF there. Drop them in the BFF. All right? Drop them now in the BFF right there. The BFF formula. So you use 2 points. Make sure you look good to find 2 exact points on the line. Don't use none where you have to estimate the values. If you can't find one, if they don't give you one, just look along the line. Look along the line to see if you can find a point where you know the values for sure. If you can't find one along the line, then something you have to put your ruler on the line and extend the line until you find a point that you know. Because remember, any 2 points on the line can work, you know. Any 2 points on the line will give you the same gradient, but it has to be 2 points that you know the values for sure what they are. Don't estimate anything. All right? I've seen that messed up a lot of people in CXC in the past, where people estimating a point. All right? And then now you use any of the 2 points with the gradient in the BFF formula to find the equation. All right? So that's what you do. All right. Bam. So this is an example right here. Now in this example that I showed on the board that you're looking at, let me erase everything. Right? This point up here, you know for sure. That is obviously the point 64. But I get that? That's the point 64. That point is 64. Agreed? So we know that point for sure. The problem though is this point down here. This point down here, you don't know for sure. Because it's in the middle of nowhere, see? So plenty people would say, plenty students will go and say, all right, A is 6.4, and they will say B is negative 2.8, negative 1.2, something like that. And estimating the values on this point. We don't want to estimate them. So what you do? You don't want to estimate those points. You look along the line to see if you can find any other point that you know for sure. You look, basically this graph, the way this one set up, you really not seeing any that you know for sure. Look at it. Right? There's no other point along the line that you know for sure. You look along it. Right? You know A, you know A good enough. But if you look along that line, there's no other point that you know. None of them no pass through where the grids of the graph intersect. You can know for sure. And you don't want to estimate anything. That is what I'm saying. We don't want to be estimating anything. Right? So that's what this is saying. Solution note. We cannot use the point B, which has unknown coordinates. You don't want to be estimating anything. And you look along the line, you don't see anymore that you know, but you can still extend the line. Right? So we locate a known point, another known point, C. We're going to see and use it with the point A. None is on the line that we can see for sure. But if I extend the line down here, see there? Extend the line down here, you see. If I extend the line down here, I get a known point. C right there, that I know the coordinates of C is negative, what is it? C is negative 4, negative 2. So using negative 4, negative 2, and use it with a 6.4 up here, so. And you work it and get the equation. Let me do it over on the right side. Right? Those are the points that we're going to use. Let's do it over here. All right, let's do it over here. This is smaller. I'll do it over here, right? All right. Everybody understand the reasoning so far? With that?
Yes, Dad.
Good.
Yes,
Good.
sir.
So
Yes, sir.
see there. So for the line AB, the same line, we're gonna use the point A, which is 6.4. I'm gonna use the point A, which is 6.4, and C, same line AB anyway, you know. We're using those points. C is negative 4, negative 2. All right, using those points to find the equation of the line AB. So remember, to find the equation of a line, we need to know two things. First thing we need is a gradient. And we also need a point. We're not a primary point. We have 2 points that we can use. We can use any one. Any one of those points we use. Once we have the right gradient, we can get the equation. All right? What I need is a gradient. So to find the gradient, I'm going to use the formula. Difference in y by difference in x. And then I'm going to introduce it to something else to show it. Watch this now. So the gradient of the line, we're using AC. So it's the gradient of AC, which is the same line AB anyway. Same line. Gradient is equal to difference in y by difference in x. So let's say I'm doing this point minus this point, right? I'm subtracting it that way. Remember, the direction you go for the difference in y, you must go the same direction for the difference in x. So I'm subtracting the A point minus the C point. So it's going to be 4 minus negative 2. That's the difference in the y values over the difference in x values now is 6 minus negative 4. But I agree with that. This line AB, is supposed to have a positive gradient or a negative gradient. Tell me quick. Positive or negative gradient this line is supposed to be? Tell me quick now. Positive, because it's sloping upwards from left to right. Good. So I work it out and I get a negative value. I know I do something wrong. So pay attention to these things. Everything important. So this works out to be 6 divided by 10. Why does someone get the 6 and the 10? Because the minus in the middle is a plus. So it's really 4 plus 2. And the denominator, same thing. Minus is a plus. So it's really 6 plus 4. So 6 over 10, which reduces to 3 over 5. So the gradient of the line is 3 over 5. And then now for the equation, very good so far. Don't move on and understand now. Very good so far.
Yes,
3 over
sir.
5. Good. So watch this now. So for the equation now, I'm going to use the point A. Huh?
I don't understand where to go for.
You don't understand where we get the 4 from?
No, sir, I don't understand.
All right. So the point A up here, sir, is 6, 4 now over this side. And you see the point A I wrote 6, 4. If someone get a 6, 4 for the point A, the x value is 6 and the y value is 4. You can see that on the graph.
Yes, sir.
Good. So remember, for the gradient is the difference in the y values divided by the difference in the x values. So I'm using this y value minus this y value on the numerator up here. So this y value minus this y value. That's what we get them now. You see it?
Yes, sir.
And then for the difference in the x values now is this x value minus this x value. That's what I put under here. Remember, it's rise over run. Rise is always the difference in the y values. Run is the difference in the x values. Practice. Difference in the y values over difference in the x values. Because this gradient is rise over run. Rise is the difference in the y values. Run is the difference in the x values. Good?
Yep.
All right now? All right.
Yes.
So it works down to 3 over 5. So that gradient is 3 over 5. And you can leave it as a fraction 3 over 5. Don't put no decimal. All right? So we're going to write the equation now. So the equation, using the point A, the equation becomes y minus ya equals the gradient into x minus xa. Because we are using the point A. Remember, it's the gradient and unknown point. I could use a C too, and the answer is going to be the same if I use a C. I can show you afterwards. See here? So it becomes y minus the ya is 4. But I see that the ya is 4. But I see that the ya is 4.
Yes, sir.
Man equals the gradient is 3 over 5 bracket x minus xa is 6. So far so good?
Yes, sir. Yes, sir.
All right, so I'm going to show you a simple with it. Always when you have a fraction gradient, how you deal with it. When you have a fraction gradient, what you do, you multiply the denominator across this side by these two things, and you multiply the numerator inside here by these two things. Always do that. So you multiply the denominator across there, I multiply the numerator inside the bracket. That's what you do. All right? That's how you simplify it every time when you have a fraction. So look what we're gonna. 5 times the y is 5y. 5 times the negative 4 is negative 20. All right? Negative 20 equals the 3 times x now is 3x, and the 3 times the negative 6 is negative 18. But understand that? That's how you simplify when you grade into that fraction. Multiply the denominator across on the left side, multiply the numerator inside the bracket to simplify it quickly. And then you transpose. So this becomes 5y equals, and carry this negative 20 over here, add it. Becomes positive 20. Positive 20 minus 18 is 2. So I'm gonna get 3x plus 2 over there. 3x plus 2 is that is my equation. I can leave it like that. If I divide 2 by 5, to make y alone a subject, I would get y equals 3 over 5 x plus 2 over 5. That is the equation of that line, 2 over 5. I'm going to do the equation one more time. I'm going to use the point C to show you. All right? Let me see if I can squeeze it down here. So instead, I could have used a different color. If I use C, let's put it down here. I could have used y minus yc equals the gradient into x minus xc. All right? So y minus yc equals the gradient into x minus xc. So it will be y minus, and the yc is negative 2. Negative 2. Let's put another page, you know. Equals, let me just put another page because this thing giving me hell. Let's put another page. So we're going to use the point C. Let's go another page and put it. So the gradient is, what is the gradient again? The gradient is 3 over 5. I'm using the point C, you know, all right? Gradient is 3 over 5. All right, let's show you. We're going to get the same equation. All right, so we're doing it at a different way. The gradient is 3 over 5. I'm using the point C, which is negative 4, negative 2. And I'm saying in that case, the equation would be y minus yc equals the same gradient into x minus xc. All right? So it will be y minus, let's say this thing horrible. Y minus negative 2, because the yc is negative 2. Gradient is 3 over 5, bracket x minus xc is negative 4. So the minus are some plus, you know. So let's change it. It becomes y plus 2 equals 3 over 5, bracket x plus 4. And as I said, multiply the denominator across here by those 2, multiply the numerator inside here. That's how you simplify that quickly. That means a different color to show that part. All right, let's use the blue to show that. Right, so multiply this denominator across here by those 2, multiply this inside here by those 2. That's how we do it, right? So let's see now. Go back for the red. So we're gonna get 5y plus 10, and I multiply by the 2 equals, multiply the 3 inside there, we're gonna get 3x plus 3 4 is 12. I'm going to carry this 10 over here and subtract it. Carry the 10 over there and subtract it. And you'll see that we get 5y equals 3x plus 2. Same thing I got on the previous one. 5y equals 3x plus 2. See it here? 5y equals 3x plus 2. Same thing we get on this one. And here. 5y equals 3x plus 2. All right, let me show you how we could get the gradient from the graph quickly now. Watch this now. So we got the gradient as 6 over 10 or 3 over 2, right? Let me show you something now before we move on quickly. So we wanted the gradient. Pay attention now, everybody. Pay attention. We wanted the gradient from this point to this point. All right, let's use a different color. Let's use the blue. All right, from those 2 points. Now remember, gradient is rise over running. So what you could have done from this point, you could have counted the rise up here. Counted the number of units you rise. Gone with longer. And the number of units you run across there. And the rise over run. And we have done that. Counted the rise and counted the run. Now what is the rise from here? It is 1, 2, 3, 4, 5, 6. See? The rise is 6. And the run, what is the run? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you rise 6, run 10. Rise 6, run 10. So the gradient is 6 over 10, which came down to 3 over 5. So you could have gotten the gradient from the graph by counting the rise over the run. Now, so you rise upwards, when the rise is upwards, it is positive. And because the run is to the right, it is also positive. If we were going the other way, let's use the green ink and go the other way and show you what would happen now. Because you can also have a negative rise. Let me use the green ink and show you. Pay attention. Let's use the green right here. I'll show you something, like this. Now, instead, I was going from this point down to this point. Still I can go in a direction and rise over run same way. From that point to that point, I would have to rise this way, rise, and run down, and run this way. Run in this direction. So I'm running this way, and I'm rising down. Now, when my rise is downward, it is negative, but it's still 6 units, so that should be negative 6. That should be my rise, negative 6. And when my run is to the left, this way, it is negative as well. So that will be negative 10, will be my run. So in that case, my rise over my run would be negative 6 over negative 10. Negative 6 over negative 10, and the negative would cancel just the same and still give me back the same 6 over 10, which is 3 over 5. But understand that? So you could actually do the rise over the run, count them on the graph from one point to the next. But don't worry about it. We will do more of this stuff. All right, I just wanted to show you that you could get a gradient from the graph and don't have to calculate difference in whatever difference is. You could just count the rise, count the run, and divide them just the same. All right, very good so far. Finishing up now, All right, nice and easy. Mathematics, nice and nicest subject ever. Reading the equation of a line. Last thing we're doing for the day. Reading the equation of a line. Now remember that when the line is in the form y equals mx plus c. Let's go back for the red ink. When the lines have the form y equals mx plus c. If you see a line form y equals mx plus c, once you have y alone as a subject, then this is a gradient, and this is the y-axis intercept. So if you have the equation of a line, all you need to do is bring it in this form. Then the value in front of the x will always be a gradient, and the constant will always be the c. Important thing is that you must have a y alone as the subject. That's what this is basically saying. All right? That's what this is saying. So if I give you the equation of a line, and you want to get the gradient and the y-axis intercept from that equation, you have to make y alone the subject. So since you have this on the screen, let's look over here for the time. Let's look over here fast, quickly. Suppose I just gave you this equation that we're looking at now on the right here. Let me get the blue in. Suppose I just give you this equation and I ask you for the gradient and the y-axis intercept from that equation. Right? Suppose I give you that line and ask you for the equation. I give you that equation of a line, this equation of a line. Suppose I would have started right there. And I just gave you the equation of this line right here. And I ask you for the gradient of that line. As the equation of a line. And I ask you for the gradient. And also ask you for the y-axis intercept. I don't have y alone as a subject. I have 5y. I need to get rid of that 5 and leave y alone as a subject. Because I'm trying to get it in the form y equals mx plus c. I'm trying to get it in that form. So I don't want 5y, I want y. So what would I have to do?
Sir, divide each side by 5.
Very good. Just divide by 5. Right? I would have to divide by the 5. Let me erase everything. This thing really slow sometimes. You have to bear with me, you know. Technology. Right. I would have to divide by the 5. If I divide by the 5, right? If I divide by the 4, Lord. Come back to this, right? If I divide by the 5, I'm going to get y equal, divide each of the values by 5. Okay, I'm trying to set out in the form y equals mx plus c. You know? This will become 3 over 5x plus 2 over 5. Then my gradient m will be this value right here, 3 over 5. And my y-axis intercept value will be 2 over 5. Such that the coordinates of my y-axis intercept will be 0, 2 over 5. That will be the coordinates of my y-axis intercept. That's what I mean by reading the equation of a line. When you get an equation like this, for example, and you want the gradient and the y-axis intercept, you have to bring it in the form y equals mx plus c before you can try to read it. That's what this slide is all about. So let's just go through it fast now. Fast and finish for today. So the equation of a line must be placed in the form y equals mx plus c before we try to identify the gradient m and the y-axis intercept c. You have to put it in that standard form first. And if you like to ask questions like this, especially in multiple choice, and ask them paper 2 as well. All right? Note that y alone must be the subject. Can't be 2y, can't be negative y, can't be 5y, can't be 3y, can't be half y. Has to be y alone as the subject. When y alone is the subject, the value in front, the x is the gradient, and the constant term out there is the y-axis intercept. All right? Very, very simple. So look at this example. 2y equals 4x plus 3. And you want the gradient, and you also want the y-axis intercept. You need to move that 2. How do you move that 2? Divide that equation by 2. So you divide each of the values by 2. When you divide each of the values by 2, that's what we get. 2x plus 3 over 2. Meaning that the gradient is 2, and the y-axis intercept now c is 3 over 2. Means that this line crosses the y-axis at the point 0, 0, 3 over 2. Next example. If I give you that line and I want the gradient and I want the y-axis intercept, I need to transpose it and leave y alone as a subject. I need to express it in the form y equals mx plus c. So I need to move the x and move the 3. So you move the x first. And you get that. And I'm trying to get the form y equals mx plus c. So I'm going to write as minus x plus 4. I'm trying to get the x value in front. Now, minus x is just the same as minus 1x, really, But then, no, I'm going to divide through by the 3. So I divide through by the 3, and I'm trying to get it in the form of y equals mx plus c. So I'm not going to divide everything by the 3. I'm going to do them individually because I want to see the value in front of the x, and I want to see the c value by itself. So I go and I divide them individually by 3. Bam, like that. And so it becomes negative 1 over 3. That being 1 over my m is negative 1 over 3 plus 4 over 3. So that way I know that my c value is 4 over 3. But understand that? But good?
Yes, sir.
All right. So class done. Your homework between today and tomorrow is to watch over the video and do the examples that we did by yourself. Do the examples we did by yourself. You also have the notes. You're supposed to have the handout. So it's the same thing that I presented on the slide. Same thing in the handout. So you can look back to your handout as well. And the examples that we did, because all the examples that we did were basically from the same handout, from the handout that you have. Work those questions over by yourself. Somebody saying something?
Yes, sir. I didn't get the handout.
All right. So you need to just give me a WhatsApp later. You have to get the handout at the bookshop at KC. All right. So just link me later and I can send you the information. All right. Just link me and I send it. Just link by WhatsApp and I send you information. But you need to just make sure you master everything that we did today before we move on now to other stuff. Parallel lines, perpendicular lines, and some other little sugar nice things that we're going to do with this topic. We're finishing this topic this week. Next week we're moving on to a new topic. Next week Sunday is a new topic. We don't need to spend 3 and 4 weeks on this easy thing. So we're moving on to a new topic next week. So to move on to that new topic next week, we need to understand this topic fully to move on to that topic next week. We're working our way up to transformation and vectors and matrices and these things, right? Which are some section 2 topics. So next week we're doing a new topic. So by Wednesday, we're doing the classwork. So tomorrow, we'll do the remaining parts of this topic. And then we're going to do some practice questions as well. And then on Wednesday, we're going to practice some more questions, right? That you'll get for homework. And we'll also do a classwork on Wednesday. So your homework for today is just to look back over what we did today, just revise what we did today, try to see if you can get understanding of what we did today, practice some of those simple examples, and then tomorrow now, we'll finish it off, do some examples, and then you can go off and now do some of those questions in the handout. All right, so that is it for today, guys. All right, body good? But all right?
Yes, Dad.
All right.
Yes, sir.
So, good. So remember, you have to finish up the thing, you have to complete the thing by practicing. Do your homework, do what I tell you to do. All right, don't joke all the thing. This is a straight A subject, Mathematics, It's a straight A subject. Everybody's supposed to get 1 is straight A. Just do what I tell you, and that will happen. Just do what I tell you, and you're sure to get it. Practice. Do what I tell you to do. I learn your individual strengths and weaknesses over time, and I know how much work to give each of you so that they can master this thing. Some persons definitely just need to do more work than others. It don't matter. We'll do what we need to do to get over this subject. All right. So if it's 10 hours of work you need, you just do the 10 hours of work. If it's 3 hours of work you need, you do the 3 hours of work. You do what it takes to get the straight A's in the subject. If you need to talk to me every day, you talk to me every day. If you only need to talk to me 1 day a week, you talk to me 1 day a week. But we'll do what we need to do to be successful in the subject at the maximum. All right? And remember, we're not trying to do this thing. We're doing this thing. It's not a trial and error business. We know what we're doing in this subject. All right? So you don't have to have any doubt. Just talk to me, make you communicate, and you'll be fine in the subject. All right? So if you don't understand something, let me know. All right? If you can't do it in the class session, I'll link you up and we'll have a little one-on-one and clarifying like a thing you're not so certain about. All right? So just let me know what does that mean each step of the way, and just do all the things that I tell you. So what I tell you to do today, go and do it. Go and watch over the video when I post it. Look back over the notes. Redo the question that we did today. That is your homework. We'll continue tomorrow at 3 o'clock. All right? Okay. Bye, guys.
Have a good day, sir.
Bye, sir. Have a
Bye,
good one.
Dad.
Bye.
Bye, sir.
Okay. Bye, Kai. Bye, everybody.
Bye, sir.
Bye-bye.
Bye, sir.
Okay. Bye.